Okay, this is the first in a little series of videos that I'm going to be making to help out all cadets doing Celestial, either for Sam Pearson's class or for Oceans, or just in general, because my content will be coming from the Celestial and Terrestrial tests in Labware. I'll be doing each question individually, but this one will just be the first question overall in this series, and I'm going to make it into a little playlist. This is, of course, since it's Coast Guard Celestial, it's going to be slightly different from real life operations. So this shouldn't be used for navigating in real life, just for the purpose of passing certain exams. Some of this will be the same, but you, at this point in your maritime career, you probably already know that there are some contrivances to how the Coast Guard runs their exams and differences that are included for the purpose of balance for the exams, but that you wouldn't ever run into in real life. So for the purpose of these tests, for the combined Oceans and Terrestrial test, and I'm going to be skipping all of the terrestrial content that is not in some way related to Celestial. You'll need a pencil, TI-30XA calculator, a nautical almanac, 2 plotting sheets, really just both sides of one for the 2 fixes that happen in the Celestial test. And some scratch paper for working out the equations, and your Rude Star Finder. This is permitted on exams, but the Pub 249 is not. I lent my 1981 almanac out, so I'll be using the digital one that is available for free from nauticalalmanac.com. TheNauticalAlmanac.com is the 1981 Nautical Almanac. So, for the first question, this is number 1 on this terrestrial test, and the USCG reference number is 50287 for Labware. At zone time 1444, on the 28th of July, in DR position, latitude 40 degrees 56.8 minutes north, longitude 167 degrees 12.4 minutes east, you observe an amplitude of the moon. The upper limb of the moon is on the visible horizon and bears 299.3 degrees per standard compass. The variation is 1 degree east. What is the deviation? So, since the upper limb of the moon is on the visible horizon, this is the indication that the moon is on the celestial horizon. So you don't need to use the additional table in Bowditch 2 to do the correction here. We're given our zone time, 1444 zone time, and we'll add our zone description to get universal time. I know that the labeling in the book is GMT, but in the 21st century, we call that UT now. We have our position in latitude 40 degrees 56.8 minutes north, and a longitude of 167 degrees 12.4 minutes east. The longitude most directly gives us our zone description, and I recently learned about the DMS to DD button on our calculators. So if you are at 167.1224, then hit second plus, that converts it to 167 degrees. 167 degrees, 12 minutes, 24 seconds. Divide by 15 to get a zone description of minus 11. 14 minus 11 will be 03. So we have a UT time of 03:44 on July 28th. Then I'll need my declination of the moon for July 28th at this time. So my O3 declination of the moon is 20 degrees, 9.8 minutes north. With a D value of 3.6 minutes per hour in the plus direction. 3.6 times 44 over 60 means that my correction will be plus 2.6 minutes. Meaning that my O344 declination will be 20 degrees, 12.4 minutes north. As usual, the formula for the amplitude is that A equals sine to the negative 1 of sine dec over cos lat. So I'll convert my 12.4 divided by 60 plus 20. Take the sine of this number, divide it by 40.5648 second plus cosine equals arc sine. So my A will be since my moon is at 299 degrees per standard compass, it's in the west, so I'm west 27.2 degrees north. I'm 27.2 degrees north of west. Therefore, Zn equals 270 plus A giving me 297.2 degrees true. True virgins make dull company at weddings. 299.3 degrees per standard compass as given. 1 degree east as given. So 297.2. We're adding west, so we minus east. So subtract 1. 296.2 degrees true. Minus plus 299.3 for a deviation of 3.1 degrees west. So my answer is A.